Hello everyone, this is Nandi from MIDAS, and I'll be presenting a bit on bridge modeling in MIDAS Civil and the TMH7 applications. In the course of this session, if you have any questions, can you type in the questions box? Okay, so this is the content of today's presentation. First of all, I'll give a brief about MIDAS Civil. Then how or what are the features for village modeling, the vehicular combinations and vehicles specific for South Africa, and then the moving load optimizer. Okay, so first off, let's have a look at a bit on MIDAS Civil. So MIDAS Civil is a complete comprehensive bridge engineering software. Right, so any kind of bridge that you could possibly think of, it could be modeled and modeled quite easily in MIDAS Civil, be it steel, concrete or composite or even timber if you would like, and any type of bridge. Okay, and it's not just a component of the bridge but the complete thing. So your superstructure, substructure, everything could be done. Even if it is certain general structure, then that too could be modeled in MIDAS Civil, but just that it doesn't have any quick way of modeling it. Okay, so what type of bridges can MIDAS Civil handle, very easily? So it could handle all your conventional bridges, your culvert bridge, frame bridge, slab bridges, then the precast spliced bridges, integral bridges, steel plate girder bridges and steel box bridges. For the advanced ones, it has staged segmental bridges, which is your balanced cantilever, then the one which is quite widely used in South Africa, the incremental launching method, the movable scaffolding, the precast segmental and full staging method. And finally, structures like cable stay bridges, extrude bridges and suspension bridges. Now some of the other features which would be useful when we go into bridge modeling. For a building, generally you do not need to go into the time dependent properties of concrete. When it comes to bridges, the duration of the construction, the exact age when the load is applied, all of these affect the final forces which would be acting in the structure. So for that, we'll obviously need to have the time dependent material properties. So for creep and shrinkage, we have CEB FIP 1990. I think this is quite widely used in South Africa. Besides that, we have other international standards as well. So you just need to give certain basic input and the creep and shrinkage behavior is automatically incorporated in the software. So you could just click on show results and you could check out your creep coefficient, your shrinkage strain. Okay, so graphically you could interpret whether the things are being taken up in accordance to what you want or is there something that needs to be changed. Similarly, the compressive strength behavior, again in accordance to CEB-FIP, this could be incorporated. So again, other standards as well. Then another thing is moving load definitions. Again, bridges, the vehicular load plays an important role. So just last year, depending on our client demand, we have gone for moving load definitions in accordance to the South African standard. So first off, you select the load code, which in this case would be South Africa. Then you just define the vehicle. So we have NA, NB and NC vehicles. Besides that, if you have any custom vehicle which is sometimes required, a very special vehicle, then that could also be defined. So define the load code, the vehicle, the traffic lane. So what is the direction of movement of the traffic? You just need to give that. And then you define the moving load case. What type of combination is it for NA, NB, NC, or for a very peculiar type of bridge, if you want to go for user-defined vehicular combination, then that can also be done. Okay, now let's have a look at the grillage modeling. So first of all, what kind of bridges would basically require grillage modeling? The foremost and the most basic is the pre-stressed composite girder bridge. This can be modeled as a grillage. If not, some people even prefer modeling, girders as beam elements and deck as slab. That can also be done. But one of the preferred method is grillage, as the result extraction is easier. Similarly, for steel composite bridge, your transverse bracings, deck, all of this could basically be modeled as a grillage. And finally, if it is a very wide multi-cell box bridge or a wided deck bridge, then that also needs to be modeled as a grillage. So the software can basically generate a grillage automatically for these kind of structures using the wizard. So that's what I meant when I said MIDAS Civil is convenient or customized for bridges. So these things could be generated very quickly. So, basically how could this be modeled? So one is our basic method, the manual modelings, create nodes and elements, define the static load cases, moving load lanes, pre-stressing tendon profiles if applicable, and define the construction stages. Okay, so this is a manual way of getting things done. And the thing that could be done in MIDAS Civil is getting this done with wizards as well. So you have auto definition of all the above components. So with a wizard, you just use certain basic inputs and all the above parts of the manual modeling would be automatically generated by the software. The advantage of using a wizard is, in general, you could create a reusable template with this. So if I talk about a highway project, so there would be multiple bridges which would be having similar profiles. So using a wizard, you can create a base template wherein you just change a couple of dimensions and your new model would be immediately ready. So it helps a lot when those kind of projects are to be taken up, and you can go for quick generation and modification. So if you are having a skewed bridge and you want to change the alignment of your transverse elements, you want to do something like that, or if there is a bridge with curvature, so those kind of things could be done very quickly. Okay, so again, saying is easy, but I think it would be much better if I could show you how things could be done. So let's go for a software demonstration. Okay, so once you start MIDAS Civil, this is how the screen would basically look. I have a couple of questions, but I think I'll get to those in the later part of the session. Okay, so once you start MIDAS Civil, this is how the screen would basically look. So at the top, you have the ribbon menu, okay, wherein you could just go from left to right, and all the process that you need to do for generating a model could be done. So first of all, you set the view, then you set the structure type, and you can use the wizards which are available over here to generate the model. Or if you have something very peculiar which can be done with the wizard, or even if you want to edit the model after you have generated it using the wizard, you could go to node and element, and here you have our basic operations of copy, trim, and those kind of things. Then you define the material and section properties, the boundaries, the loads, and you perform the analysis. Okay, so since we are talking about grillage, so let's try generating one basic grillage. So I'll try to use the base wizards, not the grillage wizard directly. I'll show you how you could do it using the base wizard. So if I go to beam, and here I can type, say, 20 at 1. Okay, so this basically means 20 elements of 1 meter length would be added. And I could define the material and section. So in MIDAS, at all the locations where you can give some input, there is a 3-dot button kind of thing. So if, say for example, in this case, we have not defined any materials. If I want to define a material right now, I could just click on these 3 dots and it will take me to the material definition dialog box. Click add, could select concrete here, I could select any of the international standards, say let us consider Euro right now, and I could select the concrete material. So its properties would be reflected over here. Now in case you don't want to use this property or you want to modify these properties, so you could set this standard back to none, and now these properties are editable. Okay. So in this way you can define the material. Also, we have this kind of minimize button in the big dialog boxes. So in case your dialog box is going out on the screen, so you could click on this small minimize button and you could click on OK. Okay, so material definition, now that is available over here. Similarly, we can define a section, but I won't define one right now. So let's just put one number over here and OK. Okay, so my single beam is created. So let us just create this beam transversely 5 times at say 3 meter distance. So I'll just select it by clicking here, select all, and I can go to nodes and elements now, translate elements. So I could enter over here 3 meter and 4 times. Basically one beam is already created, so I want it to be created 4 more times and apply. Okay, so my longitudinal beams are created, and now if I want to create the transverse beams, so I just select these nodes, I go to extrude. Okay, again now this would be in y direction, so again I'll enter 3 meter 4 times and apply. Okay, so that's it. Quickly, my grillage geometry is generated, but this is just the geometry. Now if I want to add the section property to it, so I could go to properties, section properties, you can click on add, and these are the various types of template section properties which are available. So under DB user you have the steel I section, T section, your rectangular section, these kind of properties. I'll just save this one. Okay, then under values, so if you have the properties and you want to manually enter the values, or you want to edit the property values, so those values could be edited over here. You could put your own thing. Okay, then SRC, so steel and concrete composite section, so this could be used for your say composite column kind of thing. Then steel combined section, now this is quite rarely used. Then we have PSC sections, so these are the ones which are mainly used in our case. So we have PSC 1 cell, 2 cell, 3 cell, N cell, PSC mid, PSC I, half box, so this could be used for manually generating the grillage and the value. Then obviously a bridge would have tapered section. The support section is flared up and the mid section is quite slender, so those kind of things could be handled over here. So this is valid for all your database templates as well as your general sections. Then for PSC bridges, PSC grillage bridges, generally we go for composite I or composite T kind of section, so that could be defined over here. And then there is steel girder. So let us just define composite I for now. Composite I. BC is your slab width, DC is thickness, symmetrical section, and I'll just quickly enter a couple of dimensions. Then HL3 is 1, HL4 again 0.15 and 0.5, BL buttons 0.5, BL2, let's make it 0.75, and BL4, let us make it 0.3. Okay, so you could quickly see how the section would look over here. Then since it is a composite section, basically we'll have to consider the equivalent properties. So these values that you see over here, these are the ratios, the elasticity ratio, the density ratio, the Poisson's ratios, and the thermal coefficient ratio. So you can enter these values manually, or you can select the material from the database. So for girder, say I select this material, and for slab that material, and for girder this material. So the ratios would be coming in automatically. Then we have offset. So the drill is that we have modeled. We'll be applying the load at the top, right, at the slab top location. Your moving load would be applied there, your bearing force load, SIDL, everything would be applied at that location. So for that, I'll change the offset to center top. Okay, so this big red square that you see, that's the location where my single line would represent this section. Okay, so I go for that. And okay. Okay, so I've added my longitudinal girder. Similarly, I'll add one dummy transverse beam. So that would be a rectangular section. Now this I'm defining for slab basically. Say slab, height of 22, width of 1, top, okay. Okay, so I have defined the longitudinal and the transverse element properties. So if I want to select only the beams which are, perpendicular to the global y-axis, so here I could select Y. This is basically my selection filter. Then I could click on select all. For transverse, I'll apply the slab property. Okay, it's just like that. You select it and you drag and drop from the tree menu, and that property would be assigned to it. So if I check 3D view now, so this is how it looks. Okay, my eye girders and my slab. Obviously, the transverse elements which I have created right now are just connecting the girder, so they won't be visible up to this point. If I want to extend it, then that can also be done very easily. So I'll show you for one end. What I can do is I'll just select these nodes. I can go to extrude function, and I can just enter that this would be slab. So you can select the property here. I'll just enter that 1.5 here and apply. Okay, so if I want to extend the slab, I could very quickly do that. Okay, so right now, this amount of time that we have taken, I know it's not quite high, but what we have done is we have just generated the geometry, right? We have not applied the load, we have not done anything else. So if this needs to be done quickly, then we come to the next part of it, which is the use of wizard. So I'll just open a base model in which I have already defined the material and the section property. Okay, so I'll be using this model. So in this model, I have already defined the materials and the time-dependent behavior. So I'll show that how we came to that part. We can go to properties. Over here, we can define the time-dependent material properties. Okay, so you could click on creep and shrinkage over here, and this dialog box will come up. You can click on add, but right now I'll just modify. Okay, so this thing comes up. So over here, you could select the standard, which particular standard you want to keep. So I have kept it as C, the FIP 1990. Then you could enter the characteristic strength of concrete, the relative humidity, what is the notional size. Now this is the notional size that you just want to use for your manual calculation that you could see over here. So you can click on show results and you can see the creep coefficient and the shrinkage string. If your material is loaded at 10 days of age and loading end is 10,000 days, that is your service life. Okay, you can edit this to see different values. Okay, you can just click on redraw and it will show you. Okay, now that's what this is used just for your manual verification. In reality, the software will calculate these things based on the actual construction sequence and the actual notional size of your section. Okay, so this was creep and shrinkage. Similarly, for compressive strength, you could click on compressive strength here, modify. Again, you could select different international standard, enter the compressive strength values, and okay. If you want to change the units anytime in the modeling, you could do them from over here at the bottom of the screen. Okay, your length unit and your force unit. Okay, so these are the sections that have been defined. The mid section, which has been defined as a composite PSC value type section. Similarly, we have a support section, which is a T type of section. Then we have tapered section. So you just need to select the properties at the I end. So you could import the file or import the section. Similarly for I end and J end, so software will automatically calculate the tapered property. Then the diaphragm sections have been defined. Okay, and now let's just go to the wizard. So under structure, I'll go to pre-stressed composite girder wizard. And I need to enter these things. Now what is this? So first of all, the layout. So what type of girder am I using? Is it precast or is it spliced girder? So I can select that. Then modeling type. So whether I want to create an all beam element type relief model, or whether I want to use deck as plate and girder as frame, or whether all of it as plate. So those kind of things could be done. You need to give the span information. So now this 2 at 33.5, this basically means it will create 2 spans of 33.5 meter. If you have something irregular, you could enter that as well. Say 20, 25, 20, that kind of thing could also be entered, and it will create a 3-span bridge. This is the overall deck width, the transverse direction. We could see it from the guide diagram. Okay, then whether your structure is with pier and pier cap or without it, you could select it. So all this input here, what it basically means, you could see from the guide diagram. So you could just click on this guide button. Another window like this opens up, and you could see the elastic link length, which you would be giving over here, the transverse length, which you would be giving over here, the spacing. So this is the spacing in case you are having 2 piers at one location. Okay, so all these inputs could be interpreted from the guide diagram. Okay, so this particular input basically means my stiffness in the vertical direction, and Ky and Kz are my stiffness in the transverse direction. This X, Y, and Z are along the link local axis. Now since my elastic link or my bearing would be vertical, so that is why the Kx value is quite high. Okay, so in case your bridge is having a curvature, so you could just click on this radius, and you could enter the radius over here. So a curved geometry would be generated. If that's a skew, you could enter the skew angle, say 25 degrees, so skew would be generated. But I'll do this after generating our basic model. So let us say I'll keep it as it is. Then the section tab. So here you have to enter things like, okay, what is the thickness of your deck? How many numbers of girders are there in your bridge? What are the material for different parts? And how many number of diaphragms are there in one span? What is the distance between your transverse elements? This is for creating the grill edge. And where we are using what type of section. So I'll just open an existing wizard. Okay, so this is the wizard. So this is the stiffnesses that you would be using. And the section. So here for certain part, I am using support section, then I am using tapered section, then mid section. So these kind of inputs could be provided. You can give even different inputs for span 1 and span 2. Then your tendons. So how you are providing your pre-stressing tendons. Now again, what are the different types that you could provide? You could go for straight, hard, or curved. What does this all again mean? So we have this guide diagram. So you could click on that, and you could see over here what the inputs mean. Okay. So if my tendon type is curved, so basically I need to enter first of all curved number of tendons. So that is quite clear. Transverse distance S. So that you can see from the guide diagram over here, S1, S2. So this is the distance from a reference line. Now where is this reference line? That we have kept at center. Okay, so the transverse distance at 0. So all my tendons are lying in the same vertical plane at the center. H1 is 0.5. H1 is from here at the support location from the top. H2 is say 0.57 over here. So H2 is from the bottom of the girder in the mid location. So you enter that. So these inputs have been done for 3 tendons. What is your checking stress and when you are grouting it? Then the load. Okay, so you'd be considering the loads, sulfate and all of those would start acting before composite, then certain loads would be acting after composite, then the varying force loads. So you could give inputs for those over here, their density, their thickness, then your crash barrier width, your median width, all of that input could be provided over here. Then the construction stages. So again, you could click on guide and how your construction would be processing. Okay, so this is the type of construction staging that would be followed. Okay, and if you want to enter the reinforcement, then you could define those over here as well. Okay, so the reinforcement, very minor reinforcements have been defined over here. Okay, and with that done, you just need to click on OK. And just like that, right, what we had done over there manually was we had created a grillage which was straight, mind you, and we were just able to generate the geometry. But with the grillage wizard, we are able to generate the entire model with the construction stages. So if you say stage 1, so that's only substructure. Stage 2, so your girders are in place. I'll just remove the nodes so that the view is a bit better. Okay, so stage 2, only your girders are in place. You see, it's only girder, no slab right now. Stage 3-1 means the wet concrete has been poured on your girders. Then now your slab has been cast. And then there are your long-term stages. Now over here, if you notice, my transverse elements are parallel, rather perpendicular to the main girders. They are not parallel to the skew. Okay. So I'll just, if I want to change that, I want to make those parallel to the skew. Okay, so I'll go to the base stage and I'll just undo the model which I have just created. I'll go to the wizard again. Okay, and I had given, in the wizard there was a skew angle. Okay, so this is kept at 20 degree. Now if I want to change the alignment of my transverse elements, I could just go to section and instead of perpendicular, I'll select skew over here. I select OK. And now my transverse elements are parallel to the skew. There's one question. Can you show the link between the pier cap and the deck? Yeah, sure. So basically over here, if you look in the 3D model, okay, I'll just make it 3D right now. So it may look like things are quite well connected, but in reality, what you have modeled are just these line elements, right? So this is your deck and girder location, this is your pier cap, and this is your pier. Now these have to be properly connected to transfer force in them. So for that, what we do is we create links. So the boundary, I will just activate the elastic links and the rigid links for now. Okay, so what are these elastic links and rigid links? Now when I say a rigid link, so that is a link which would be connecting my girder top location to my bearing top location. So this is a rigid body link. Now in our theory and analysis, we know that a plane surface remains plane before and after bending. So that is the reason why this is created as a rigid body link, and below that we have an elastic link which would be given stiffness in accordance to your bearing properties. Okay, so this is at the abutment location. If you look at the pier cap location, so vertical rigid link connecting the girder top to the bearing top, then your bearing, and a link connecting your pier cap to the bearing bottom location. Okay, so that's how the connection is worked out. Okay, there is one more question on how do you define the ground conditions with a spring element. So if you want to define your ground as a spring, we have two options for that. One is you can go to boundary, and if it is something like this and you want to give it as a single spring, so you just select the side node, you go to point spring, and you could give the different stiffnesses for translation as well as rotation. However, if that's not the case, and if you want to go for say springs for your pile footing, so in that case we have this integral bridge option. So here you can select whether you are defining the springs for abutment or piles. Okay, just need to select the soil type, what is the ground level, the diameter of the pile, you can enter this, the unit weight of the soil, the earth coefficient at rest, and the internal angle of friction. Just select it and click apply. The software will automatically create your springs in vertical direction as well as your lateral directions. Okay. Okay, there's one more question now. Can the program tell you if the tendon profiles are insufficient or wrongly placed? Now in this case, the software will give you warnings if it is very wrong. So if the tendon profile is very much out of plane, then the deformations and everything would be abnormal, and from that we have to judge that yes, the tendon placement is not proper. But the final checking, so after you have applied all the loads and you perform the analysis, so from the applied stresses, you'll have to learn whether, you'll have to interpret whether the tendons are applied properly or not. Again, one more question, can you model settlement? So yes, that can be done. So under load, we have this settlement option. So you could create a settlement group. So say I'll give a name G1. I select this node. I give minus 0.01 meter. Add. So the settlement group is created, and I create a settlement load case. So LC. I just select the group. So basically this is applicable when you have say multiple supports. So in this case I'll have to even create groups for abutments. So minimum 1 and maximum 3, and I click maximum 2, and I click add, and the software will perform permutation and combination, and it will give you the results for the worst settlement. Okay. Okay. So again I'll just proceed with the demonstration. We'll take up the questions later. So what I have shown to you right now is the modeling for PSCI girder type bridge, the grillage model for PSCI, wherein with just those basic inputs, your construction stages and everything have been defined. Your self weight would be taken, the wet concrete load. So this you can see in the base stage, you can obviously see it. So this is the second stage, and in the 3-1, so this is my wet concrete load which has been activated, and then in 3-2, when my slab is actually activated, so now the slab weight would be taken up automatically, and hence the wet concrete load is deactivated. Okay. And then if you want to check your tendon profiles, so these are the tendon profiles that have been applied. Okay, so this was PSCI girder grillage. You can see how easily you could modify your model. Similarly, I'll take up a steel composite grillage. So again, this is one of the base models. So the material and the section properties have been defined. So I'll go to structure, steel composite, and so this is again just like PSC composite, a similar wizard option. So I'll just open up an existing wizard file. So this is the wizard that was created. Again, here we have option all frame, some part is plate, but for grillage generally it's all frame. Now in this case, I have given a radius of 500 meter. So on the section, okay, so again the inputs for the different material types. But for steel composite, the additional part is the bracings. So you could click on first of all guide. So this part of the guide says where the brace would be placed, how the alignments of the brace would change. Okay, so all of these kind of inputs are being governed from this tab. So if I go to bracing details, so over here again, what is my bracing type, whether it's bracing or whether it's a single beam. Okay, so all these inputs would be provided. So the alignment of the bracing, the alignment of transverse members, the girder sections. Similarly, the load tab and the construction stages. So if I talk about construction stages, so where the pouring is happening in what stages. So first of all, this D1, D3 and D5 would be poured, and then this. I'll show you how, or basically this is going to affect. So I'll just click OK, and I'll again disable the node display. Okay, so this is my grillage model that has been created. Now this one I have created without the substructures. Okay, so you can see your bracings and everything is in place. Now we had a look at that construction sequence part of it, right? So I'll come to the 3D model again. I'll come to the first stage. So first of all, my steel parts, my girders and my braces are in place. Second stage, the load for concrete is in place. 2. Now you notice there are certain locations where the slab is cast and certain locations where the slab is not cast. So this basically is my negative moment zone. At my support location, due to the load which would be acting at the center, there would be negative moment. Negative moment means tension at top, and my slab is very weak in tension. Obviously, concrete is weak in tension. So for that, what is done is initially the concrete is cast in the mid part of your span, and at a later stage, the slab is cast for the negative moment zone. The reason being, all the negative moment for the slab dead load in the mid span is now taken by the steel part of the girder, and the slab would have to take part of negative moment only coming from loads which are activated later, like your wearing surface load or the moving loads which are coming in, and so on. Okay, so that sequence of casting is also taken care of by the software. Okay, again, so if I want to change something over here, I'll just undo it. I'll go to steel composite. I can change the span, say 25 to at 40, so I can make it one span of 40 meter and span of 50 meter. Okay, and if I want, I could make the rate. Also, yeah, there is one more option. There is multi-curve option. So if you are having a S-curve kind of profile, or if there is a transition curve kind of thing, the radius are changing, then those kind of things, if you want to give super elevation, then that can also be done over here. But I don't have input for that, so I can just show you this for right now. And I click OK. So your bridge with the new alignment, and if I look at the supports, so first span was short, second span 40, and the third span 15 meter. Okay, so all of this could be done. Now, okay, there is some question about exporting this to Revit. Yes, part of it could be done. So I'll just show you how things are done. So you could go to File, you could go to Export, and you could export it to AutoCAD. You could export it to frame section for solid, frame for plate. You could export it to IFC file, which is common for most platforms. And there is also an export to Revit option, but for that we have to install an additional tool. Since I don't have Revit on my system, I have not installed it, but yes, that is available. I will show you a document on that towards the end of the session. Okay, so this is the grillage for steel composite. With the similar options, you could create a grillage for your box girder bridge, multi-cell box girder bridge. So I'll just open an existing wizard for that. Okay, so this is a wide cell, wide box girder bridge. So this kind of grillage could be automatically generated using this grillage model option. You could click on that and you could see the different options that would come in. Okay, so your layout, this is the common thing in all the type of wizards. The span, so where your diaphragm is located, and if you have different sections to be used in different parts, then that could also be done over here. Okay, so what is at abutment location, what is at bent cap location, what is in between. So you could notice there is a minor change in the size of the section when I change it over here. Or you can do that for different spans. Then your section, so where you are dividing it. So basically the software will divide the wide box girder into different parts like this, and it will calculate properties for this part of the section. It will calculate the transverse property considering the top and bottom slab. Okay, and that's all. That would be done automatically. If you want, you could change where the division is happening. You want it web based, so at the center between the two webs, or such that slab is equal for all the girders. So you could do it in the way which you are convenient with, but the most common one is the web-based divisions. Then the transverse arrangement. So what type of arrangement it is, whether it is, footpath on both the sides and the median, or whether it is just one part of the bridge, one carriageway, so that you could select. Then you could auto calculate the bearing locations, so where the bearings are located, that it will take in automatically. The loads that you need to consider, the tendon profiles, and if you wish to provide, you could even provide the reinforcement. So with all that done, you click on OK, and this model would be generated. So I'll again just take up certain parts so that it's easier to visualize. If I just take this part and I activate it, so these options over here are for activation, deactivation, to view selected elements. Okay, so this is how it has done. Clear? You could refer to any of the section properties that is required. So these are the answer boxes. So if you look at the longitudinal direction properties, so you could see the properties for each part. Okay, if you want to check anything, you could click on show calculation results, and what is the bending stiffness, the area, the centroid locations, all of those could be checked. Okay, so that is the grillage model. Now let us come back to the presentation. Okay, so now the part specific for South Africa, the vehicles that have been considered. So we have considered any vehicle. For longitudinal direction, obviously this is the nominal distributed lane load, which you are all very conversant with. So we have used this formulation, and we'll obtain this curve depending on the loaded length. Similarly, the nominal axle load, which has to be placed at the worst location in each lane, that has been considered. And any load, the TMH7 suggests also you could check for a 100 kilonewton concentrated load, but we have not incorporated this automatically, as this could be applied manually quite easily at the required location. For the longitudinal distribution, we have considered the loaded length and how that would govern the applied load. So for NA, how much length is being loaded at once, that affects the overall distribution of the load. So just have a look at this. In this case, the image that you see right now is the NA load application when the loaded length increment is set at 3 meters. Okay, so just pay attention to this part which is highlighted. If I change this loaded length increment from 3 meters to 1 meter, then the way in which the load has been applied is changing. Okay, so this is taken care of. For transverse distribution, what the software does is it basically considers 4 influence lines for each lane, and that is how the load would be applied. And also the narrow bridge consideration. So if your bridge is quite narrow and it won't be accommodating multiple lanes, if you want to apply the traffic load as a factored load, then that has also been considered. Okay. Then the NB vehicles. So this is quite easy. We have NB36 and NB24. You just need to select the factor and that load would be taken automatically. Similarly for NC, now this is the area load. So the factors that have been given, for A, B and C, these parameters can be, would be taken up automatically with the load. Okay, there are a couple of questions on loading, but this is being covered in the later part, so I think that would be answered there. Okay, and similarly, if there is a special vehicle, then in that case, you could define your own custom axles, and you could define complete vehicle where the axles are placed. Even if it is unsymmetric, then that could also be taken care of. Okay, then the load combinations. So if the code suggests that there are a very basic combination, so the entire carriageway is just loaded with NA load. So if I say that that is my combination, then the software will automatically, load all the lanes. And if I'm checking for the worst bending moment at the center of the span over here, at the pier location rather, sorry. So for that, how the load would be placed. So since my last span is longer, more load is kept over there, lesser load on the adjacent span, and the knife edge load or the nominal axle load at the worst location. So that is done automatically. Okay, now if I say the similar things about NB loads, for maximum bending moment at the center of the span over here at this location, so this is the NB positioning. Similarly, if I want the worst due to NB at this location, then obviously my two axles at the either end of the vehicle are placed quite apart. So just defining a single lane would take care of all the NB cases for a single carriageway. And then simple NC load. So NC load, the code says that it has to be at the center of the carriageway and with 1 meter offset on either side. So you could just define one lane at the center of the carriageway, or if it is some other profile, then that can also be defined and the software will load automatically. Also, if you are having multiple carriageways, then that load combination is also accounted for. And similarly, the user-defined loads could also be applied. So if we talk about the junction location, so how you want to go for a combination at that location. So for that, if you want to give a user-defined way of getting it done, that can also be applied. Then the optimizer. Okay, so there have been certain questions on combinations. I think that answers that. And now we'll come to the optimization. So how that would work. So first off, we have a regular optimization. So for that, what will happen is, if I define a single lane, so the software will place the vehicle at the center of that lane, at the extreme left of the lane, and extreme right of the lane. Okay, so that could be just from the image, but a better explanation could be given from this particular animation. So if what you see on the screen is my bridge, with the yellow parts being the crash barriers, so this black dotted line is the center of the lane. The red lines are the extent of my lane where the vehicle could be moved. So the software will check for extreme left, extreme right, and center of the lane throughout the entire length of the bridge. Okay. Then we have multi-point optimization. So what you need to do is, earlier we defined a single lane. Now you need to define the carriageway width, you can say. So you define the entire carriageway width. You let the software know what is the width of individual lane. And if there are any margins, then those could be given in. So how that would work is, say again the same bridge, the center line of my carriageway. And this red zone is the edge part where the vehicle is not allowed, say. If I say my carriageway is to carry 2 vehicles, then with just that input, the software will check the entire bridge for any vehicle position that could be encountered. Okay, so all of this could be covered with just single lane definition. Also, we could obtain the concurrent member forces. So generally for substructure design or for bearing design, you require the concurrent forces which are acting. So that could be obtained. So you could obtain those in form of table for frame elements as well as for your support locations. Okay, so if I check the reactions due to moving load, so this would be the reactions that the software will directly give you. This is the envelope. But if you want to see the concurrent reactions, then this is what is happening. So earlier it is 1730 at the center and 880 at the abutment location. But if I check the concurrent reactions with the maximum reaction at the central pier location, then at that time the reaction at my abutment location was just 302. Okay, so this is the concurrent reaction table. Okay, again let's go for demonstration. So I'll just open up a basic model. or rather let us create one again. We'll go to structure, please just composite, and I just open up the wizard, change the scale to 0 for now, and okay. So this is the model that would be generated. Now I'll just activate the top, that is the deck location, to change the views from over here. Select window, top location. This is the location where my vehicle load would basically be applied, right? So now let us go to loads, moving load. Okay, so over here we can select South Africa, traffic line lane. So this right now, the first lane I would be defining is for NC vehicle. So add, say NC lane, the name that I want to give. The width, say I'm keeping it as 5 meter because I'll be considering 3 meter width of the NC vehicle. I'll be keeping it at the center of the carriageway. This is the traffic lane optimization, the regular optimization. You check on this particular option and the software will check for placement at left, right and center of your lane. So I'll check that on. Then whenever I'm working with grillage, I have to select this cross beam option. So that lets the software know what are my transverse elements for distributing the vehicular load. So I'll select the cross beam over here. Over here, I'll select the transverse elements on which this cross beam or rather the load distribution will happen. Now if you are having a skew bridge, so you could enter the start and end skew angles. You could select the moving load direction, whether it is moving in forward direction, in backward direction or in both the directions. Okay, so right now we'll keep it forward. I click on the first point, the second point, and again now my OK button is basically going out of screen. So I'll just use this minimize button and click OK. So my NC lane has been defined. Okay. For NA and NB, what I'll do is I'll click on this and I'll go to this moving load optimization option. Okay. So for NA and NB, this single definition is going to cover all. So I'll click add, say optimized lane, for example. The optimized lane width, so this is the width of my carriageway. So say if I give 14 meter, individual lane width, in this case will be 3.5. Analysis lane offset, so if my first lane is placed over here or first location is checked at this location, so the next placement in transverse direction would be 1 meter. Okay, so this is just how closely you want to check. The lesser the distance over here, the more vehicle placement positions in transverse direction and the more time for analysis. 1 meter would usually serve the purpose. The margin, the distance at the sides, and the eccentricity, in this case again 0, cross beam, the beams, again forward direction. I will click on the first point, the last point, and okay. Okay, so both my lanes have been defined at the center location. Now the vehicles, so I'll just click on vehicles, add standard, NA, NB or NC, so I'll add all the three. So NA, if you want to change the loaded length, instead of 1, 1 is the default value in fact, so if you want to change it, instead of 1 you could make it 2.5, so that can also be done. Okay, so that is your NA. Similarly you can add NB. So for NB you can select 36 or 24 over here. And NC, again for NC the code says that whether the opposite contribution or the relieving effect is to be considered or not, so that you could consider by checking on or off this option. Now if you want to go for user defined vehicle, you could click on add user defined. Here also we have the standard types, so you could add it all the parameters. So for NB, instead of 36 you want to go for something else, 28, then that can also be done. Similarly for NC you could change how many number of options are there for this A, B and C and what is the load. and then there is permit truck. So this is the completely user-defined vehicle. Okay, so we have added the standard vehicles, the moving load cases, so for moving load cases, you click add. Say I'll give NA case. These names are just for our better understanding. So for NA, we'll be going for moving load optimization. So you could select optimization over here, NA vehicle, optimized lane. Minimum vehicle distance is the distance between individual vehicles. This could even be set to 0 if required. Keep it 0.5 for now. Number of loaded lanes. So since my carriageway width is 14 meters, so this would be 4. I say okay. Similarly, a case for NB. So for NB, I can just go to moving load optimization again. NB optimized lane, and okay. And for NC case, type NC, select the lane, and okay. Okay, so in this way, all my possible combinations have been defined for this particular bridge. Okay. Now with that done, you just need to click on perform analysis and everything would be taken care of. The total time of analysis for this bridge is around 500 seconds. So not to waste that, I have created such model already and I have analyzed it. So I'll just open that model. Okay, so we'll just have a look at any questions in the meantime. Okay, there is one question about combination. So for that, the combinations, yes, the one thing about combinations is these combinations could be created, even after the analysis. So I can go to results, load combinations. Say if I want to go for concrete design, I could create combinations of my own. So I'll just, copy this one. And if I want to add moving load into this, so I could select my particular vehicle case. And that's it. My new combination has been created, LCD5. I can instantly check its results. So to check the results, I'll go to results. Say if I go to forces, beam diagrams. So the LCD5 that we have created, if I go to legend means that will, show me on the side. So these are the moments which are acting. If I could change the units, kilonewton, meter, and instantly the legend would also be updated. If you want to change that to something like decimal values, that makes more sense. So you could do that, and now you could directly see the values. Okay. Okay, for some people the screen was stuck. I'll just redo that part. So this is an analyzed model. So to see the results, basically you could just go to results, forces, beam diagrams, LCB5. Yeah, I created the load combination as well. So for that, results, load combination. Okay, under concrete design, you could create your combination. So I'll just create another one. Say I have this one, but I want to add moving load to that. So I'll click on that, copy it. So that's just come over here, and I'll add, say, any vehicle to that. So that's done. I want to add certain factor. I could make it as a factor. Okay, so my combination is ready, and I can see its results. So the combination 6 is the one that we have recently created. So I'll go to CB6 and legend over here, apply. Okay, so these are the moments. The units, you can change it anytime and the results would be instantaneously updated. Okay, so you could check beam forces, you could check the stresses, you could check the deformations, you could also check the results in stages. So at any stage, what is happening? So in the first stage, obviously, just a pier cap. Second stage, your girder, this is the moment with the pre-stress, you can check the summation. The fifth stage, what is happening, and then your post CS. So this is the one where you check the results with the load combinations and stuff. Okay. You could also check the deformations, obviously. The next question is about yeah, can you make the envelopes? Yes, you can make the envelopes as well. That can also happen from load combination. So over here, you see this type over here. Right now, it's additive. So if I want to create an envelope of say LCD 5 and LCD 6, I'll just type over here, say ENV. I'll change this to envelope. Okay, and over here I'll select the load combination LCD 5 and LCD 6. Okay, so with that done, my envelope case is ready and I can check its results from directly right now. So here I'll just go to envelope and apply. Okay, so these are the results for the envelope of those two cases. Okay, now again we'll just come back a bit to the moving load part of it. So if you want to see any vehicle position for some specific moving load results, so you could go to moving load tracers, you could go to say reactions. So if I want to see the maximum reaction happening at the pier bottom, so I'll just click on this node, which is node number 591, and I apply. So this is the NC vehicle placement. I just disable the values. Okay. So this is the NC vehicle placement for the maximum reaction at the pier bottom, which is coming at about 209 tons. Okay, similarly, if you want to check for moments, the beam forces and moments for say maybe an A vehicle, so you could select any beam, rather a longitudinal beam would be preferred. Okay, so you could select any beam over here, apply. So this is your NA vehicle placement. Then I'll remove the values. Okay, so this is the NA load, the knife edge load and the UDL values. Similarly, if you want to check for NB, so again for NB, right now it is showing to me at this location because I am checking for this member. I am checking for this member which is somewhere on the other side of my deck. And for that again, I'll just select the key element which is this and apply. So now my NB vehicle has moved at that location. Okay, so basically all the different parameters required are covered over here. Now again, let's go to presentation for a brief moment, since this is a presentation for light version introduction. Okay, so we are done with the software demonstration. So these are already existing clients in South Africa, SMAC, MacMac, ARQ, Arup, and so on. These are just some of the clients. This is not an exhaustive list. That's it for today's presentation. If you have any concerns or queries, you could write to Ashish on ashish@midasit.com. If you have any technical queries, you could visit our global support center, which is globalsupport.midasuser.com, and you could drop us a question over there. We'll definitely get back to you. Thank you very much.